Hey everyone, and welcome. If you're a technology or innovation leader, or honestly, if you're just building, scaling, or even thinking about deploying advanced AI workflows, you are in the exact right place today. We're diving into a really brilliant, highly practical explainer based on a guide called Mastering Multi-Agent Systems. It's by Prateek Babsar over at Galileo AI. We're going to unpack the core strategies for real-world multi-agent development and really discover where AI architecture is actually heading.
So, to kick things off, we really need to ask a serious question. And it's one that's honestly been kind of haunting development teams for the past year or so. Can one AI model really do it all? For a long time, the prevailing industry assumption was just a resounding yes. We all kind of believe that if we just had a single, sufficiently massive model, it could handle incredibly complex reasoning, intricate coordination, and flawless execution all by itself. Basically, we were looking for a silver bullet, right? But as we're about to see, the reality of actually building enterprise-grade applications quickly shattered that assumption.
Okay, let's dive into this highly structured curriculum. We've got 4 parts today. First, the single model problem. Second, the multi-agent solution. Third, the collaboration challenge. And finally, number 4, the roadmap to mastery.
All right, starting off with section 1, the single model problem. Here's where the industry hit a massive bottleneck when trying to scale single models. Now, what's really interesting about this slide is the contrast here. We used to have this incredible expectation, right? This dream that one powerful model could act as the ultimate brain, just juggling reasoning, coordination, and execution totally seamlessly. But the harsh reality that developers actually faced in practice, it's completely different. Interconnected tasks literally cannot be reliably managed by one model alone. When you ask a single model to hold the context of a multi-step process, reason through weird edge cases, and execute perfectly, it just breaks down. It hallucinates, it forgets things, or it simply gets overwhelmed. And here is the truly fascinating part. The industry basically tried to patch this problem using brute force, but as the author explicitly points out, it just wasn't enough. Throwing more data at it? Not enough. Longer context windows? Not enough. Better, more complex prompts? Still not enough. You can feed a single model mountains of data. You can give it an infinitely long context window and engineer the most elaborate prompt in the world. But it doesn't matter. None of that fixes the underlying architectural bottleneck. At the end of the day, a single model is still just a single point of failure when you're dealing with highly complex, interconnected enterprise tasks. Which brings us to section 2, the multi-agent solution. This is a total paradigm shift that fundamentally changes how we approach complex AI workflows. This guide introduces multi-agent systems not just as a slight iteration, but as a fundamentally different approach. Instead of relying on one all-purpose model to be the, jack of all trades, multi-agent systems distribute work across specialized agents. I really want you to think about that shift. We are moving away from the monolith and moving towards specialized distributed work. You are essentially building a specialized team, where each agent owns a very specific piece of the overall puzzle. And by breaking that monolithic model down, you unlock 3 huge core advantages. First up is parallel processing, meaning different agents can actually work simultaneously. Second is specialized expertise, so one agent could be optimized purely for data retrieval, while another is built purely for coding. And third, this is a big one, built-in validation. Agents can actually check each other's work. Tasks that once completely overwhelmed a single model suddenly become super manageable when they're handled by a team of specialized agents working together in tandem. Let's move to section 3, the collaboration challenge, and see how this builds. Because, of course, this new distributed architecture brings its own inevitable complications. There's a pivotal realization from the guide that goes like this. The same collaboration that makes these systems powerful also makes them more difficult to manage. That right there is a crucial warning for technology leaders. Multi-agent systems are incredibly powerful, absolutely. But the second you introduce multiple agents, you introduce severe management hurdles. You're no longer just managing a single model anymore. You are managing a complex, interconnected network. The text details some very specific friction points that just multiply as these systems scale. First, there's agent context. How do you actually ensure Agent A knows what Agent B just did? Second, memory requirements. Storing and recalling information across a distributed system is vastly more complex than a single model. And third, clear communication rules. Agents need strict protocols on how to talk to each other. Otherwise, you risk infinite loops or total data loss. Make no mistake, these are very serious engineering challenges. So how do we fix it? That leads us to section 4, the roadmap to mastery. This is where the guide gets highly actionable, giving you a step-by-step resolution to overcoming these exact scaling challenges. To tackle these hurdles head-on, the author lays out a really comprehensive step-by-step roadmap across 5 chapters. It methodically takes you from that initial evaluation phase all the way to building a production-ready system. Step 1 in Chapter 1 evaluates the 7 primary advantages. Step 2 examines true need via coordination costs. Step 3 focuses on choosing from 4 key architectures. Step 4 tackles mastering context management versus memory, and it all culminates in Step 5, building an actual LangGraph system. Let's break down the critical insights from these steps. So the crucial point is right here in Chapter 2. Before you write a single line of code, the guide gives you a framework to answer one major question. Do you truly need multiple agents? It forces you to take a step back and weigh the incredible benefits we just talked about against those newly introduced coordination costs. It is entirely possible, and it happens a lot, that for your specific project, the overhead of managing those communication rules actually outweighs the benefit of parallel processing. This chapter is basically there to ensure you only invest in multi-agent systems when they add real, justifiable value.
Now, if you determine you do need multiple agents, Chapter 3 helps you navigate the structural design. Developers have to choose between 4 key architectures here: centralized, decentralized, hierarchical, or hybrid. Choosing the right structure is absolutely vital because it essentially dictates the org chart for how your specialized agents are going to interact, report to each other, and execute their tasks.
Moving on, Chapter 4 makes a highly critical distinction between context management and memory. And spoiler alert, they are not the same thing in a multi-agent system. The guide explains exactly how they differ. Even more usefully, it outlines 4 common failure points that developers run into when managing them, complete with practical solutions. This is exactly where you learn how to keep your agents from, well, losing the plot during a really complex workflow. Finally, the whole thing culminates in Chapter 5. And this isn't just theory anymore, it is highly practical. The roadmap finishes by providing a step-by-step LangGraph example to actually deploy these systems. It shows you exactly how to build, test, and monitor a production-ready multi-agent setup. It basically takes all the rules, the architectures, and the memory management strategies from the earlier chapters and applies them directly to a real-world deployment. Bringing it all together, we look at the source text itself. This guide by Pratik Pavsar is positioned as absolutely vital intelligence for technology and innovation leaders. It acknowledges that, yeah, the industry has finally moved past that naive belief in the all-knowing single model, and it hands you the exact blueprints you need to navigate the complex but highly rewarding world of multi-agent development. It is quite literally a roadmap to making these systems reliable in the real world. Which leaves us with this final, provocative thought based on everything we've explored today: are multi-agent systems worth your investment? You now know the undeniable advantages of parallel processing and specialized expertise. But you also know the steep management costs of agent context and communication rules. The framework to decide is out there. I highly encourage you to dive into the source text, weigh these factors for your own projects, and find your answer. Thank you so much for joining me for this explainer. Keep building, keep learning, and I'll catch you in the next one.